everyone. Today we are going to start Law of Definite Proportions. So, Law of Definite Proportions was given by French chemist Joseph Proust. Here you can see the picture of this chemist Joseph Proust. And Joseph Proust was actually performing an experiment in the lab. Inside the lab, he was just trying to synthesize copper carbonate. Now, जब उसने copper carbonate का synthesis किया, then he found that the elements which are present in the lab synthesized copper carbonate are actually present in the naturally occurring copper carbonate. इसका मतलब ये है कि नेचर में जो copper carbonate exist कर रहा है उसमें जो elements हैं और लैब में जो बना रहा है वो सेम है. इसके अलावा एक और ऑब्जर्वेशन दिखा कि ये जो एलिमेंट्स हैं वो एक डेफिनेट प्रोपोर्शन में प्रेजेंट है और यहीं से लॉ ऑफ डेफिनेट प्रोपोर्शंस ओरिजिनेट हुआ. सो अकॉर्डिंग टू दिस लॉ, in a given chemical compound, here you can see in a given chemical compound, the elements are always present in a definite proportion by mass. Or in other words, we can say that a compound is always formed from a fixed ratio of its elements. Just for example, we can consider H2O. So here you can see this is H2O molecule. Just a second. This is H2O molecule. Now in H2O molecule, we have two hydrogen atoms. So there are two atoms of hydrogen and one atom of oxygen. If we consider its mass, then it is for two atoms of oxygen, it is 2 grams per mole, and for one atom of oxygen, it is 16 grams per mole. Now, if we simplify this ratio, this ratio is 2:16, and if we simplify this, it comes out to be 1:8. So, इसको और आगे हम elaborate करें, तो हम देखेंगे कि किसी भी particular compound में same तरह के elements होते हैं. There are same elements in a particular compound. So this is the first point you can see here, right? So this is the first point. The compound contains same elements. Moreover, in the same proportions by mass, right? जो भी elements present होते हैं वो same होते हैं और साथ में उनका proportion fixed होता है, definite होता है, definite proportion by mass, and irrespective of its source, no matter what the source is. इसको बहुत beautifully we can understand this. अगर हम वाटर को लेक वाटर से ले लें या सी वाटर से लें और या फिर टैप वाटर से लें, रहेगा फॉर्मूला क्या? H2O. So in case of H2O, there are two atoms of hydrogen and one atom of oxygen, and the ratio remains the same, 1:8. और अगर हम इसको परसेंटेज बाय मास से भी देखें तो देखिए ये हाइड्रोजन और ऑक्सीजन का अगर हम रेशियो देखें तो क्या आ रहा है? 1:8 आ रहा है. नाउ 1:8 के रेशियो में अगर हम परसेंटेज ऑफ हाइड्रोजन बाय मास अगर हम कैलकुलेट करें, मास परसेंटेज ऑफ हाइड्रोजन, देन हम कैसे कैलकुलेट करेंगे? वेट ऑफ हाइड्रोजन अपॉन टोटल वेट ऑफ वाटर. सो दैट कम्स आउट टू बी 1/9 इंटू 100. तो ये आ जाएगा 11.11%. सो हाइड्रोजन का परसेंटेज क्या होगा? 11.11%. सिमिलरली अगर हम ऑक्सीजन का परसेंटेज निकालना चाहें यहाँ पर, तो परसेंटेज ऑफ ऑक्सीजन वुड बी 8/9 because weight of oxygen is 8/9 into 100, and then it comes out to be 88.89%, right? So here 11 और 89 का जो रेशियो है परसेंटेज बाय मास का है. Now let us consider another example. We are going to consider example of carbon dioxide. Now in this case you can see amount of carbon is 12 gram, amount of oxygen is 32 grams. So what is the ratio of carbon and oxygen here? So in every source, whenever we get carbon dioxide from any of the sources, the elements would be carbon and oxygen only, and then their ratio would be 3:8. 12:32 or 3:8 is the ratio of carbon and oxygen. Now, if we calculate the percentage of carbon in carbon dioxide, so we can calculate in the same manner. 3 divided by 3 plus 8, that is 11 into 100. So, what is the percentage of carbon here? 27.27%. Then percent of oxygen is equals to 72.73% because it is the mass of oxygen is 8. So 8/11 into 100. Now if the percentage ratio is of carbon and oxygen is like this, 27.27 is to 72.73, then that means we can say that it is carbon dioxide. तो किसी भी सोर्स से हमें कार्बन डाइऑक्साइड मिलेगा, उसमें कार्बन और ऑक्सीजन का परसेंटेज सेम रहेगा. एथिल अल्कोहल का एग्जाम्पल लेते हैं. एथिल अल्कोहल के एग्जाम्पल में अगर हम देखें, देयर आर 2 एटम्स ऑफ कार्बन, तो कार्बन का वेट हम निकालेंगे 12 grams per mole into 2 because there are 2 moles of carbon atom present. So यहाँ पर अगर हम ग्राम्स में निकालना चाहें तो 12 ग्राम्स पर मोल इंटू 2 मोल्स ले रहे हैं, मोल मोल कैंसिल आउट हो जाएगा एंड देन इट कम्स आउट टू बी 24 grams. Similarly, it has 6 atoms of hydrogen. You can see 1, 2, 3, 4, 5 and 6. So there are 6 atoms of hydrogen. So weight will be 6 into 1 grams per mole and it comes out to be 6. 1 atom of oxygen is also present. So 16 grams per mole into 1, that is 16 grams. And molecular weight of C2H6O, that is ethyl alcohol, is 46. परसेंटेज वेट ऑफ कार्बन हम निकालेंगे तो यहाँ पर हम देखेंगे बाय वेट परसेंटेज बाय वेट ऑफ कार्बन इज इक्वल्स टू 24/46 into 100. So it is 52%. Similarly, we can find out the weight of hydrogen, weight of oxygen also. So ethyl alcohol will always have the same composition of elements, that is 52% of carbon, 13% of hydrogen and 35% of oxygen by weight. So let us consider some problems related to law of definite proportions. Let us consider this problem. Suppose you have 4 grams of hydrogen to form water, then how many grams of oxygen will be required to form water? Right, so we are talking about water here. Now in case of water, we know that the ratio of hydrogen and oxygen is always 1:8, right? We have already discussed this. So if this ratio is 1:8, then definitely we can calculate the grams of oxygen with the help of 4 grams of hydrogen in order to form water. So we can write in this manner: 1:8 is equal to 4 grams of hydrogen for x gram of oxygen. So in that way we can calculate x grams of oxygen will be required, which is 4 into 8, that is 32 grams of oxygen. Right? So this is the idea, that we always know that in all the compounds, elements are present in fixed proportion, definite proportion by mass, and keeping in mind this concept, we can calculate the percentage or the ratio of another atom with respect to the one atom. Now let us consider one more problem. If there are 42 grams of hydrogen in a sample, so hydrogen का एक हमने quantity देखा, 42 grams present है in a sample of pure methane. Now here we are considering methane here. So in methane, what is the ratio of carbon and hydrogen? It is 12:4. So 12:4 means 3:1 we can write, right? So carbon and hydrogen का ratio 3:1 है, and on that basis we can very easily calculate the percentage or mass of carbon present. So if mass of carbon is x gram, then we know that mass of hydrogen has been already been given, which is 42 grams, and in that way we can calculate the mass of carbon, which is 3 into 42, that is 126 grams. So this is how we calculate the mass of one atom with respect to the mass of other atom, because we know that the atoms or the elements are present in definite proportion in any particular compound, and this follows law of definite proportions. So keep practicing, dear students. Try to understand the concept and the application of different laws. We have already discussed 2 laws, law of conservation of mass and law of definite proportion. Watch my next video for law of multiple proportions. Thank you so much.